Let Jack take it away.
including me.
I can see your slides. Ultrasonic sensors.
Okay, but I mean, should I mute my microphone?
No, you don't get to mute yours.
Darn. Okay, you ready?
Ready?
All right. So, hello everybody. Welcome to today's training session. This, I think, is second to the last one. I think there's one next month that we're going to talk about capacitive. And if my plans work out right, I want to show you guys a way to demonstrate relatively easily the smart level sensors. So hopefully that works out. Today's topic is ultrasonic sensors. This next line is for John Takis. It's a sound solution for sensing applications. Do you like that, John?
Jack, I'm so pumped up to hear the rest of this.
Oh, that's good. I hope we don't have a blowout. Just everything fails. Anyway, so we're going to talk about ultrasonics. So we might as well get started. As I figure out how to use this again. There we go. So my objective on this is by the end of this presentation, you guys will be familiar with some applications. We're going to discuss some terminology, different operating modes of our ultrasonic sensors. We're going to go through a lot of application considerations, things that we really need to keep in the back of our mind when we're applying these guys. The portfolio from Balluff, and then also what our competition has out there. So anyway, so first question is, why ultrasonic sensors? These are actually a pretty good alternative to photoelectrics. And the fact that the target material absolutely doesn't matter like it does with photoelectrics. So we can do films and transparent objects and liquids fairly easily. Again, there's some application considerations you have to take into effect. But basically anything that can reflect a sound wave can be a good choice for ultrasonic. Obviously, color doesn't matter at all, unlike photoelectrics. And in difficult environments where there's dust and spray and paint mist or what have you, typically does not affect an ultrasonic sensor. Used to, I think years ago, temperature and humidity used to affect them pretty badly. But with the newer sensors, that stuff is compensated within the sensor. I actually pretty well touched this. Why not use photoelectric sensors? One of the nice things with ultrasonic is you can set them up in basically proximity mode or like a diffuse sensor, and you can get some long ranges out of these guys. I mean, you can get some ranges out up to 20 feet that you can't do with a diffuse type photoelectric sensor. Surface color, reflectivity. I mean, clear glass to a ultrasonic sensor is the same as a shiny metal plate. It doesn't care. So we can get good sensing repeatability out of these guys. Then the analog response is good, and also so is the resolution on these ultrasonic sensors. So in some cases, it's actually a great alternative to photoelectrics. I know. I think I was actually talking to Mr. Takis one day. He had an application where he was trying to detect a tire and do some measurement, and he was looking at the sidewall, I believe, and I suggested ultrasonics because, again, it's a good surface to bounce the sound off of. And anyway, so there's a ton of applications and industries you can use these sensors in: material handling, automotive, packaging, pharmaceutical, tires, paper and printing, and just a number of applications these sensors can be used on. Moving along the same line, you can use these for web monitoring. Basically, you can use them for loop control. You can use them to see if a web's been torn. You can do height and width measurements. Typically, these are going to be like with the 30 millimeters and 18 millimeter sensors, so you can set these up as a three-dimensional measurement, so you can look down and also look at the side, look at it from each side. So it's a good alternative to photoelectric there. You can do presence verification, so whether or not there's actually an object there, if a pallet's full or empty, if containers have product inside of them. You can use multiple sensors and look at a big area if you want to. Robot positioning with ours, with the versions that are in the R06 type housing and also the M12 housing. You can verify positioning with robots, put these on the end effectors, and they're fairly lightweight. Another application is wire or thread breakage. So the key thing here is obviously you have a small object. So you're going to want to use a relatively small style sensor, but you also want to make sure that the object always stays within the cone, the sound cone coming out of the sensor. Stack height, just basically like presence verification. So whether or not, the height is of the stack of paper or cardboard or what have you is at the right height. You can do that. Fill level in silos and bunkers and containers for bulk materials, sand, gravel, just about anything. Not so much foam, but just about any type of other thing. And then object detection is just that. Again, kind of like a diffuse photoelectric sensor. You can use it to count objects. You can get discrete outputs out of them. And then positioning. Again, you want to make sure that the surface is good, but you can do positioning with these guys and get an analog signal out of them. Here's some pictures from some different applications. So this is basically clear plastic off of a payoff reel. So they're actually looking down to see what the diameter is. Works a lot better with ultrasonics than it would photoelectrics because of the clear surface. Concrete block stacking to see if the stack is at the right height. This one is for collision avoidance. It's one option to do it that way. Again, presence loop control. This would be great on paper. Making roofing shingles or roofing paper and stuff like that. So you can do good loop control. Again, even steel. This is an application from life science to verify that vials are filled at the proper height. And then this application here is to ensure that the packages have been sealed. So if you have a package that's not sealed like these are, it's partially open, it's a great application for that. Again, more loop control, robotics, silo fill. There you go, John. Got one for tires for you. So we can do tires. I think this is a type of a payoff reel for like rubber or something like that.
Both of those are tire, yep.
Are they? Cool.
Both of those are tire.
I'm trying to take care of you.
You're a good man, Jay.
I know. I try.
Don't let Leah tell you differently.
I don't pay attention to her. Anyway, and then this one here, this is a life science application. So these are what they call microplates. So they put various liquids in there for testing and so forth. We actually have a demo set up this way that we're going to take to some life science shows. So we put this focusing attachment on there. We can look down into these microplates. And typically these cavities are maybe 1 centimeter in diameter or maybe a centimeter deep. So we can detect those levels with the ultrasonic. So what are some good targets? Water, paint, varnish, wood, plastic, steel, concrete, glass, hard foam. So hard foam being stuff like maybe styrofoam or the insulating foam that you see on the pink insulating foam that they sell. Then some poor targets are cotton and wool, or a lot of fabrics, soft carpet, foam and soap. I was actually seen where the foam in beer is what they call hard foam because of the carbon dioxide. So actually, according to what I read, you can detect beer foam with an ultrasonic. Any powders with high air content, again, soft foam, and flour is actually one of the worst things. They say it absorbs sound very, very well. So um, nice chat there, Bon and Will. Anyways, some more thing on the targets. The ideal target should be solid with a smooth surface. If you don't have that and you have a rough target, you can still do it, but it's obviously going to have a weaker echo. The shorter distances could cause an echo, or an increased distance will provide better reflections. However, if you're doing something like thread or wire, you're going to need that shorter distance. And then obviously a larger object gives you more surface to reflect the sound back to the receiver. So if you go with if you have a smaller target, use a smaller sensor, get closer to it. So how do these guys work? These are basically time of flight sensors. So there's a transducer inside that sends out a burst of about 200 kilohertz sound waves. So some people can hear them. Personally, I cannot. So it shoots out this sound wave and it's in the shape of a cone, and that's very critical. I'll talk about that in a second. Anyway, the sound wave goes out, hits the target, it's reflected back. The sensor calculates the time from when it's sent out the sensor till it receives the signal back. Again, just like time of flight with a photoelectric sensor. Okay. Inside with a ultrasonic sensor, it's a three-dimensional detection zone. Okay, so that's kind of key. I was talking with some folks yesterday about an application, and we kicked around using a ultrasonic, but again, this sound wave goes out in the shape of a cone, and it's three-dimensional. So if there's a flat surface here, there's a possibility you might start getting sound waves bouncing around or echoes. So you have to keep in mind of what that cone shape is and the size of it. How they determine what the detection range is they take standard targets and they move them from side to side. So in this case, for the red zone, that's typical target is either a 10 millimeter or 27 millimeter rod that they move back and forth across there to determine the red zone. To determine what the blue zone is, or the maximum range, they use a 500 by 500 millimeter plate and they move it back and forth to determine what it is. We cannot detect anything outside of the blue zone, so you're going to want to make sure you keep it within that area. Some definitions that are really key. So the first one is a blind zone, or some folks call it a dead zone. If there's any objects that get into that blind zone, you're not going to detect them. Or if you do detect them, it's going to be very unreliable. So make sure you keep that in account. And it's just like some photoelectrics have a blind zone in those as well. Your operating zone, or your scanning area here, that's the assured area of detection. So anything within the minimum and maximum range, you're going to be able to detect those best. Your detection range is where you're going to get a fairly decent measurement or detection. But once you start getting out into this area here, you might start getting some unreliable results. So you want to make sure that you're within basically the assured area. And again, the target size, that has to keep in mind. So if you have a small target, you want to use typically a smaller sensor, just like you would a photoelectric. You can get some different operating modes out of these sensors. So the first one is background suppression, and it's just like a photoelectric background suppression. So with this, you have control over the hysteresis. You can ignore the background. So you set up your switching point just like that and totally ignore the background. The level demo that exists out there that has the levels that has the RS6 ultrasonic sensor in there. The range on that ultrasonics is much farther than what the tank is. So basically it's kind of working in background suppression mode. So I taught it what the low level was, taught it what the high level was. And so it's basically the BGS mode. Thurston just brings up a good point. Sensing distance is based on the target size, so the applications must be tested very thoroughly too. Just like capacitive sensors and some other stuff, is we really need to make sure these things are tested in the worst condition. Diffuse, like I've said, this is similar to diffuse sensor or diffuse photoelectric sensor. So any object that's put out there is going to reflect the sound back. Again, the better the harder the surface and the better that the surface can reflect sound, the better everything will be. But again, it's just going to be just like a diffuse sensor. Anything that gets within that area, we're going to be able to detect it. And with these ultrasonics that we have, we can get a discrete output, or we can get an analog output, or both. There's also a window mode. So as long as the object stays within those two limits or within that window, it'll be able to detect that. You'll notice that a lot of photoelectric sensors now that are coming out, like the R254, you can set things up in a window. So it's something that's pretty common, even in pressure sensors. Then last but not least, we have analog. So the analogs can be 0 to 10 or 4 to 20 milliamp. You can scale these guys so you get a linear output. And you can also select whether or not it's rising or falling. So as the object moves towards the sensor, it could be, you can either have it falling because of the short range, or you can reverse that and have it rising. So as it gets closer, your analog output goes up. And resolutions on these sensors can be anywhere from about 25 millimeters or 25 microns or 35 microns and better. So let's talk some application considerations. Again, smooth surfaces are the best. If you have a smooth surface like glass or metal or whatever, the sensor should be perpendicular to it, or 90 degrees, plus or minus 3 degrees to the surface. If you have a rough object, say you have I know one time there was a customer that wanted to do some sort of like basically it was a dumpster and they were throwing stuff in there to see what the height was. If it's a rough object, you can have a greater angle on the mounting because you have so many rough surfaces coming back at you. Gina just asked a question. What's the most common application for window mode? Great question. Let me think about that one, Gina, and I'll get back to you. Right now, my mind is blank. Actually, my mind's blank a lot. But anyway, it's blank right now for answering that question. If you're doing temperature, say for hot metal, the one thing that you really can't do is put these in a lot of turbulence. So above a tank of like molten aluminum or whatever, it's going to be very turbulent. So basically what you're going to want to do is try to shoot this with multiple sensors, maybe go at different angles coming down in there to try that. It may work, it may not. You really got to test it. But the one thing you definitely cannot do is mount it straight above shooting down. On the front of these sensors, there's typically a foam type material. So it's obviously going to damage that foam. And the sensor probably wouldn't be able to handle it anyway. Cold, not a problem. You can do stuff if this is a cold liquid. It's not going to be an issue. Some more considerations. Vacuums. Sound does not propagate in a vacuum. So you can make some measurements in a slightly negative pressure, but as the pressure becomes more negative, if that's the right way to phrase that, your signal is going to be reduced. If you're going into positive pressure, there are some sensors that will operate up to about 85, 87 psi. I think that's like 6 bar. So you can do that. Normal precipitation, like in rain, snow, or fog, usually does not affect these sensors. The maximum range can be reduced, so you want to keep that in mind. Also, you should not let like water droplets accumulate, or snow or ice or anything like that on the surface. So you're going to, if you do that, you're going to start getting some false measurements. Dusty environments typically do not affect these sensors. Again, it's something that's going to have to be tested. But paint, anything that's hanging in the air should not really affect it unless it builds up on a transducer surface, in which case you will start having issues. Currents of air at different temperatures. Typically, you want to keep the temperature as best you can. Again, there's compensation within these sensors. And even if they're out in a windy environment, so say you had a wind temperature of like 60 miles per hour, that's only about 8% of the speed of sound. So the speed of sound is 768 miles per hour. So typically any air movement like that should not affect it. Again, test it. Let's see where we at here. Levels of foam or liquid, or doing levels of liquids with foam. Again, foam will tend to absorb the sound unless like I said, beer is is actually not a good one. That is, I fibbed earlier, so no, you don't want to do beer foam. But any kind of liquids with foams, like soap suds or any type of thing like that, you don't want to use because it's going to absorb it. The humid application, or I'm sorry, measuring corrosive metal or media with acids or alkalis. A lot of acids will attack that foam that's used on that sensor face, so it'll actually destroy it. Sometimes some of the foam is made out of polyurethane, so they'll eat it up. And different chemicals are going to affect it different ways, so you really want to be careful trying to do anything with acids or alkalis. Humid applications, the effective humidity is pretty low. So it should not be an issue. Again, temperature, we talked about that. There may be some, again, test it. Background noise. This one's interesting. So if you have this thing that's mounted next to, for instance, an airline that's leaking, it's causing a high-pitched sound, that could potentially affect your measurement and the output of that thing. So any kind of basically hissing sounds by air hose or relief valves could be troublesome. And high-speed applications, keep in mind this is time of flight, and the sensors, ultrasonic sensors, aren't quite as fast as photoelectrics time of flight. So basically this thing has to shoot the sound wave out and then listen for it to come back. And it's it's kind of slow. So we're talking about usually about 0.1 seconds for this thing to figure out exactly what's going on. So again, high-speed applications might not be the best solution.
Hey, Jack.
Yes.
There was a question that came in from Rick from Canada, wanting to know if anyone test these on rice. Might have been a slide back or two.
Is the rice cooked or uncooked?
I don't know. Rick, you want to chime in?
Yeah.
No,
Because
the rice is coming in on rail cars and loaded into silos. And I just got an application to try it out there. I'm just wondering if anybody else has tried it.
It may because the rice is going to be packed in there pretty tight. I would assume. So it should be able to work on that application.
I'm thinking so too. Just that
Yep.
you mentioned flour is not good, so it kind of
Right.
made me question the rice. But
Is it outside? I think would be my only question.
yes, the silos are outside.
But the tops of the silos are sealed, right?
Yeah. Oh, yeah. It'll be inside the silo on the ceiling, basically, the silo. But I'm concerned about the dust too as they fill it.
Yeah, that's what I was wondering. Once they start dumping that rice in there, they're going to get a lot of dust in the air. As long as it's pointed down, it might be okay.
Yeah.
Okay. It's one of those, Rick, that's going to just have to be tested.
Thank you.
Yep. So what's our portfolio look like? These products our ultrasonic sensors are actually microsonic or brand label microsonic sensors. Okay. So as we go through here, once I get into competition, you're going to see that. But our portfolio, we have M30 housings that you see here. There's different 5 different scanning ranges up to from 30 millimeters up to 8 meters. These guys have a display on the front of them, so it's actually going to show you what the distance is. And then there's push buttons on here so that you can select some of the parameters inside of here. You can get 1 or 2 switching outputs, either PNP or MPN, analog outputs, either 4 to 20 or 0 to 10. And again, the display is going to give you the actual measurement coming out. Most of our ultrasonic sensors can be synchronized. So if you have several sensors, say you had a big pallet and you were looking at to see what's being measured, you can synchronize up to 10 ultrasonic sensors so that they don't do any crosstalk. So that's pretty much on every one of them that we have. And again, you can teach this guy with 2 push buttons. The M18 housing, you can get these with the straight output, like a photoelectric, so it's going straight out, or you can get the right angle versions. These have 1 push-pull switching output. It's either PNP or MPN. It's going to figure out what's going on. You have an analog output, and again, you can synchronize these things. And you can teach these remotely by using pin 5 on the connector. And again, you have the 90-degree M18 housing. I think these are actually inside the demo van, if I remember correctly, hanging on the network wall, or used to be. There is 1 M12 ultrasonic sensor. It has a measuring range from 25 to 200 millimeters. 1 discrete output, either it's PNP or MPN. And the same thing with this, you can teach it using pin 2. And then there's the little guys here. These RO6s. These are used quite a lot. We saw a bunch of these things. You can get 5 ranges or 5 ranges from 20 millimeters up to 1 meter. You have 1 switching output, and then again you have the analog output, 4 to 10 or 4 to 20 or 0 to 10. The synchronization that you can do with this thing, and again you can teach these guys with a button up here on top. These are basically like the 6K photoelectric sensors. So basically the same layout, push buttons on top. I think the mounting is even the same. There is an option for a focusing attachment, and this is what we use for the life science applications. Um, once you use one of these focusing attachments, and I've never been able to find out what it is, but anyway, I think it also decreases the range because the sound's got to go out and back in through that small opening there. But we've done some testing on this, and we've actually tried it on a semiconductor application where on the wafer there's a notch that's 1 millimeter by 1 millimeter wide, 1 millimeter deep, and it's as thick as the wafer is. And we were able to detect that notch for positioning. So these things are really good for that type of application. And then there's the big Q80 version. We can get up to 6 meters out of this guy. It's got 2 switching outputs and then the discrete outputs. I'm sorry, the two analog versions. And then there's also the teaching on pin 5 with that. This is the latest version. This is a pressure rated version. It goes up to 6 bar on the nose gun here. Does have a display with some push buttons in it. The face is actually Teflon or PTFE. And the range on these go up to 5 meters. This one's fairly new. I think it was just released in the last couple of years. Thurston brings up a great point for the focusing attachment for the RO6. It does reduce the size, but that also depends upon the size of the target, or reduces the range and the size of the cone, and the range depends upon the size of the target. Some accessories we sell. You can also deflect the sound, so you can put this in and shoot sound at like a 90 degree. You can put focusing attachments on here. This is the one for the M18. These are the 2 focusing attachments for the M12, and then this is that one for the RO6. So competition. Obviously, Microscan. They're still selling them in the States. I see them listed on the web for from a number of different distributors and so forth. P&F is a big competitor to these products. They offer a pretty good line of ultrasonics. When we first released ultrasonics, we brand labeled them from a company called Pill. The nice thing about the new versions, the actual cone is much smaller than the Pill version was. So that was actually a good thing. Turk, they have a pretty good line. These are the Turk versions down here. They obviously have a good line of ultrasonics. Leutze, this is basically all I could find on Leutze was just these 2 versions here. You notice the similarity between Sensapart and SICK and the ones that I've just showed you. So Sensapart and SICK also brand label Microscan ultrasonics. It's interesting. The other day I had a conversation with a customer who was doing some ultrasonic applications, and he was comparing ours to P&F. He said the P&F was working actually very, very well compared to ours. And he also said the Microscan was working really well, maybe even a little bit better than ours, which at the time I thought was kind of interesting since ours is Microscan as well. So anyway, I guess it's the interpretation. Some additional ones, Siemens. These are the Siemens versions here. Balmer has their versions. Snyder actually bought a company in northern Cincinnati called Hyde Park, and they used to have some really, really good ultrasonics. I used their stuff when I was working at a machine builder. Hyde Park actually had some really cool things. Then IFM's got quite a wide variety of different sensors. Any questions, comments other than what's come in? Will had one, only diffuse styles, no through beam or no through styles. I haven't seen any. I don't know that. Thurston, you know of anybody that actually makes
I
it?
was just asking if that's like a possibility, or is it just in this?
I don't know that it is a possibility.
Well, yeah, there's people out there that do make, they do call it through beam, and it actually is like a fork style. And they make also those double sheet detector type.
Oh yeah, also like the label detectors.
Yes,
Yeah,
that's
yeah.
exactly it, Jack. That's
Yeah.
the only ones I know of for sure, because they're extremely short range when they do that.
Right. Yeah. Yeah. Because they're like what 2-3 millimeter range on that on the fork.
Yep, and then some of them are just a little bit wider, maybe 5 or 10 when they're doing that double sheet detection. And I'm not sure exactly what the through beam does to do that, but that's what is out there.
Yeah.
So
Actually,
it's really only point and shoot, which is fine. I was just asking.
Yeah.
Okay.
I actually did see a couple images of from some different manufacturers that had that fork style. So it would be interesting to know how they do perform that through beam type function. Anyway, so appreciate everybody's time. Like I say, I think I have one more of these to do, and it's going to be on capacitive. If it does what I want it to do, it should be fairly interesting. If it doesn't, I'm going to blame it on Leah.
I see people clapping at that. So
Poor me, poor me, poor me. Yeah, that's on December 17th, improving your sensor capacity.
Yes.
Mm-hmm.
So I appreciate it. I hope everybody got something out of it.
these are really great, Jack. Thank you.
Thank you. I
Can
appreciate
you
it.
throw the point in the chat? You get a chance?
I'm sorry, Will?
Will you throw the PowerPoint in the chat when you get a
Yes.
chance?
Yeah,
Awesome.
I'll have to sanitize. I have to pull the competitive stuff out of it.
Yep. Yeah, I think.
Yeah. Supposedly we get in trouble if we put all that competitive stuff in there.
I think it's fine.
So
Yeah.
I've been told.
Yeah, I think it's okay to take it out. I'm mostly interested in the front part. So, yep.
Okay. Yep. I'll stick it in there.
Perfect. Thanks, Jack.
Cool. Thank you, everybody. I hope you have a wonderful weekend and a great Thanksgiving.
Absolutely.
Stay safe.
Have a great weekend, everyone.
Yep.
Bye.
Thanks, Jack.
Happy
All right,
holiday.
Thank you.
Thanks, Jack.
All righty. Mr. Takis, keep it rolling.
Oh, I'm so pumped to go sell ultrasonics now.
I
I'm
know.
gonna try and inflate my sales numbers. Thanks, Jack.
All right, man. Stay good. Leah, the sun's shining here.
It's shining here too. I had to pull my shade down.
I know, it's awesome. So yesterday I was doing a podcast with Julie Hale.
Mm-hmm.
So, I sit by a window kind of looking out in the woods, and as we start talking, I see movement out of the corner of my eye, and there's a deer standing there looking in the window.
Oh my.
Man. My wife said she scared 5 turkeys in the backyard yesterday.
Oh wow.
It's like, quick, did you get the gun and shoot? Thanksgiving's right around the corner, right?
I know, and turkeys are hard to come by this year.
I know. Maybe I should get them and shoot them and start
Mhm.
selling
Well, I couldn't do that.
them. I couldn't either because I think it's slightly illegal. So, and I know you would miss me.
We would. We would. You just don't know how much.
Well, I think I do.
Oh no, you have no clue. All right, doing anything fun this weekend?
Me?
Mhm.
No. I just got through redoing a kitchen table that we had, the 100-year-old table.
Oh wow.
So I just got through doing that, so I guess I have to go out to my shop and clean up my mess because I'm a messy worker.
Oh, hang on just a second, Jack.
Yep.
All right, Julie was in here. We just had some birthday boxes we still needed to give out.
Oh,
Did you get yours in the mail?
yes.
All right. I'm waiting to see your cake.
Was in a meeting with Logan Welch, and I think Logan's got 4 young children.
Yeah, he does.
Yeah. Guess what they found in the box?
The glitter bomb.
Guess what they did?
He set it off. Oh, that's funny.
He did not think so.
Oh, that is so funny.
Yeah, he didn't think so. I
Oh
thought
my
it was funny
gosh.
too, but
I'm
wonder
gonna need to.
I wonder how many other people. Oops. You know?
Oh gosh, I need to call him. That's so funny.
Yeah. The other thing I'm doing today is I'm actually going to go get my booster shots. So we'll see how I'm functioning tomorrow.
Oh,
It's the
yeah.
weekend. My,
All right.
my sister-in-law got hers, and she was really sick for a couple of days.
Really?
Yep.
Oh, well, that's no fun.
So,
All right, Mr. Jack, I'm gonna get off here. I hope
hey,
you don't
have a
hope you
wonderful
don't feel
week.
bad.
Me too. Thanks. Take care.
All right, you two have a happy turkey day.
All right, you too. See ya.
All right, bye-bye.
Bye bye.